of pi over 2. So that means I need to know the sign of pi over 2. So you go to unit circle and find sine of pi over 2, which is 1. What's the reciprocal of 1? It's a tough one.
1.
It's 1. It's right, because it's 1 over 1. It sounds like I'm tricking you. I'm not. The reciprocal of 1 is just itself, which is 1. So that equals 1. All right, the secant of negative 3 pi over 2, there's two ways you could do this. You could have added 2 pi to it, which would have got you pi over 2. Or you could have said to yourself, well, a positive 3 pi over 2 is here. So a negative 3 pi over 2 would have been that same distance, but in the negative direction. No matter where you got, we're talking right here. Don't do that. Well, secant is cosine. So we're really trying to find the reciprocal of cosine of negative 3 pi over 2. So I'm looking at my cosine value. My cosine value is 0. Does that mean my reciprocal is also 0? In other words, is my answer 0 on this one? I asked that because it's probably wrong, right? Liam, what should it be?
Undefined.
It should be undefined. The second one should be undefined. So if you put down 0, you got to remember the fact that it's undefined. The reciprocal of zeros on our unit circle is going to be undefined. You have to know that. All right, tangent of 7 pi over 6. You should already have these memorized. It's just square root of 3 over 3, 1, square root of 3. We go all the way around, and what did I say we were looking for? We were looking for 7 pi over 6. 7 pi over 6 is right here, and what is that tangent value that needs to be right here? Who's got it for me? Come on, let's go. Yeah.
Square root of 3 over 3.
Square root of 3 over 3. Perfect. Square root of 3 over 3 is that answer. Who is still struggling with the secant, cosecant? You can raise your hand. I promise you no one cares if you're actually struggling with it. I just need to know. Does it make sense? A little bit?
Yeah, I just need to remember which one's which.
Yep, and it's good to recognize that. It's good to say to yourself, hey, I don't understand which is which, so it tells you to go home and practice it, right? Like, just because you don't have math homework doesn't mean you can't every once in a while let it pop into your head. You know, say, okay, cosecant goes with sine, secant goes with cosine, and then just double check it. It takes like a second. No one says you can't do that. In fact, I would do that constantly, but I like math, so. But if I was you, especially if you focused on that, just test yourself on it every once in a while. All right, but are we all good on reading the unit circle? And then just taking the reciprocal of it? All right, I think the biggest one we're going to get wrong in the test is when I ask for something like the second one there. The secant of negative 3 pi over 2, because I think a lot of you are going to put down 0. Okay, you changed. Okay, I thought I still said 0.
No, it's right before that.
Gotcha. No, you're good. You're good. I just saw a big 0 there. I'm like, you didn't change it. You're definitely going to get it wrong on the test. Okay, questions on the homework? Yes, Kim.
73.
I don't want to do that one. Can we do a different one?
Wait, what did you say?
73.
Oh, okay.
But I don't like that one, so I want to do it. It's a hard one. I'm just kidding, Liam. I'm going to do. All right. 73 is just like 71. It's all about rewriting it. We're used to seeing something where you got a b in front of the x. So I want to have a number in front of the x. I don't want to have this fraction. So I'm going to do 71 and then 72. I'm going to rewrite it. How I'd rewrite 71 is I'd rewrite it as cosecant of 1/2 times x. Because that would have been 1/2 times x over 1. X, yeah, that works out. So we're just going to have 1/2 times x. So then my period is just going to be 2 pi divided by 1/2. All right? You got that one, right? Okay. Same thing is going to happen down here. Same exact thing is going to happen down here. I kind of think of it as like the x is just falling off. It just falls off the top and goes to the side. So it falls off the top, goes to the side, and the 1 in front of it stays there. The same thing's going to happen on the secant one. The x is going to kind of just fall off. It's going to go, it's going to go boom, and it lands right there. So it kind of just falls off the top. And whatever's on the top is going to stay there. whatever bottom's going to stay there. And now we have pi over 2 times x. And that means my period, or the period for this function, is going to be 2 pi divided by pi divided by 2, which is keep, change, flip. So 2 pi times 2 over pi. My pi's would cancel out, and the period would then be 4. Is that far enough, you think?
Yeah.
Yeah? Liam?
Number 80.
Okay. Any questions on this one before I go to 81? Are we good on that? Is it okay that the period's 4? Yeah, I actually like when it's 4 because then it's just 1, 2, 3, 4, and then shifts are real easy versus trying to figure out where our pi's are. All right. I heard 80. I forgot the rest of the statement. It must have been 81 because I think that's all we had. Do you have a specific question?
Yeah, I was kind of confused on the 2, like is the 2 in the front, is that just the up or down?
Yes.
Okay.
Yep.
This is just put it at the front.
Yep. So I would rewrite that secant 2x plus 2. That gives me my up or down. Yep.
Oh, and then, yeah, okay, so I saw that and then I graphed it, and then I don't know where the asymptotes would be.
Oh, okay. Okay, so this one has an amplitude of 2. It has a period of pi, right?
Yeah.
So let's just go ahead and do that. So my period is pi. 1, 2, 3, 4 pi. So it'd be pi over 2. Half of that is pi over 4. Times 3 is going to be 3 pi over 4. I think just I'll just do 1, 2. It'll be kind of a small graph, but you'll be okay. All right, so I am graphing. So we got secant. Secant goes with, what does secant go with? I want to say it's tangent. I want to say it's, is that right? Does secant go with tangent? Are they reciprocals?
No.
No. What does secant go with? Cosine. Okay, cosine. So I'm going to graph cosine with an amplitude of 2 and then shift it up 2. So I'm going to shift my whole graph up 2. I'm just going to do that with the sinusoidal axis. I'll shift my sinusoidal axis up 2. And then my amplitude is 2. Let's do that in bluish color. So my amplitude is 2. So that means that's my amplitude. All right, then I come back down here, come back down here, come here, come here. So I'm assuming you had this or similar to that.
Oh, I see what I did. Now,
Oh, okay.
Like I skipped 2 lines.
Oh.
That kind of messed me up.
Gotcha.
I'll just do the sinusoidal axis.
Yep, just do the sinusoidal axis because then you know where your vertical asymptotes are.
Okay.
They run right through where your sinusoidal axis and your lines collide. So those are kind of your zeros right here. Okay, and then we go down, up, up.
Okay.
All right. So sometimes, especially on these, it's nice to shift my whole sinusoidal axis up because then I can see where it's colliding with my graph. Does that make sense to everyone? Are we good on that? All right, other questions from the homework? Yeah.
Well, for the same one, how did you find the period?
How did I find the period?
Yeah.
For this exact one?
Yeah, 81.
Yeah. Okay, so the period is always 2 pi over b, right? My b is right here. It's just that 2 in front of the x. So it's 2 divided by 2, which equals pi.
Oh, I think I just looked at it weird. Okay.
I think we overthought about stuff. We saw too many 2's, I think. I really think that can be, you'd be surprised how just something like that can throw you all off. Just too many 2's being in there. All right, other questions? All right, then let's get into today's lesson. And today we're going to talk about graphing tangents and cotangents. Yours should not have this sine, cosecant stuff on there. There was a saving error where I kind of combined 2 things into one when they saved. But yours shouldn't have it, so I just got to erase it off mine. Graphing tangents and cosecants. Way different than sine, cosine, secant, cosecant. So kind of take what you know about those and forget about them. All right, we're going to throw some new rules at you for these. These are just for tangent and cotangent. So we have 2 different realms. We got the sine and cosine, and then we got the tangent, cotangent world. All right. So the basic graph of tangent. What we're going to do is we're just going to plot some points of tangent values. And hopefully on your unit circle you have your tangent values written. And we should have those memorized. So you should have them memorized by today. I'm going to tell you by tomorrow or the next day. Be ready for a unit circle quiz. And I'm also going to check to make sure you know the basic shape of every one of our functions. So that means I can say sine of x and you can graph sine of x. Cosine of x, you can graph that. Secant, cosecant, tangent, and cotangent. I'm not talking about shifting it up, down, left, or right. I'm just saying, can you just draw the basic shape of it? All right, either today or tomorrow or Monday, expect a quiz on those. Okay, it shouldn't be much, because how hard was secant and cosecant graph? Just the basic one. If you knew sine and cosine, it's pretty easy, right? All right, no shifts, no nothing, just the basic graph. That being said, we're going to learn how to do tangent and cotangent. So we're going to plot some points. So we look at that right there, and I'm trying to find the tangent of negative pi over 2. Well, negative pi over 2 is going to be right down here. What's my tangent value right down here? You can look at your unit circles. It is okay. But what is my tangent value there, Liam? It's undefined. Tangent is always undefined on our vertical. All right, it's 0 on our horizontal. So that means at tangent of pi over 2 is also undefined, because that's on my vertical as well. Horizontal, tangent's always 0. All right, so that means 0 degrees or 180 degrees, or 0 and pi is going to equal 0. So this 0, 1 is going to be 0. So those are nice because they're just on our vertical or horizontal. Now negative pi over 4. Liam, you already gave me one. Can someone else give me what the tangent value of negative pi over 4 is? If you're sitting there waiting for someone else to do it, it is negative 1. Yes. Everyone should be at least flipping. All right, it's good practice. It's good practice to go back and forth. And then can someone give me the tangent of pi over 4? Yep. 1. Thank you. Thank you so much for offering answers. All right. Whenever something's undefined, on a graph, there's only two possibilities. It's either asymptote or it's a hole. With tangent, it's going to be a vertical asymptote. So at negative pi over 2, we're going to have a vertical asymptote. And at pi over 2, we're also going to have a vertical asymptote. Now, if you reach back to your Algebra 2 knowledge, if I have two asymptotes like this, there's only a couple possible graphs that we have. Either we're going to have a U-shaped, an upside-down U-shape, or we're going to have kind of a snake-looking thing going one of two directions. All right, those are only basic shapes that could fall between two vertical asymptotes. So let's plot these points. So we have negative pi over 4 is at negative 1. So that means I need a negative pi over 4. Well, that's halfway. That's halfway between 0 and pi over 4. So that's negative, or pi over 2. Negative pi over 4 and a positive pi over 4. At negative pi over 4, my tangent value is negative 1. So we're going to plot that point. Negative pi over 4, negative 1. At 0, my tangent value is 0. At pi over 4, my tangent value is a positive 1. So this is what my graph is going to look like. It's going to look something like this. A little snaky looking S thing. So my tangent value goes up. All right, from left to right, it goes in an upward motion. This is going to keep repeating itself, just like the sine curve would just go up and down forever. This will repeat forever as well. So if I was asked to draw 2 cycles, I would just say, well, the distance from here to here, 1, 2, 3. So we're just going to go 2 here and put another vertical asymptote. And this is if I needed to graph another cycle. And there would be another cycle after that, another cycle after that. There'd be a cycle before this, a cycle before this. But we're more concerned about just this one. Just this one. Because after that, it's just repeating. And what I want to note about this one thing, let's do it in purple, is how long is the period? The period is going to be pi units in length. Because from here to here is pi units, and then it starts repeating itself again. What was the period of our sine curve, and our cosine curve, and our secant, and our cosecant? Yeah, it was 2 pi. So like I said, this is a brand new beast. It is now pi versus the 2 pi. All right, so different. Kind of forget what you know about sine and cosine. This period is pi. So I'm going to go over here and fill in my period right away. It is pi. It is pi units. Let's talk about domain really quick. Yes.
What?
Oh, I thought you were raising your hand.
Yeah, no.
Oh,
Negative infinity to positive infinity.
close. So domain are x values, and it does go from negative infinity to infinity,
0.
except for here, 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 here. So it's negative infinity to infinity, except for at a ton of different places. All right. Now it's way too hard to say it's negative infinity till slightly bigger than less infinity, and then skip something, because we have to skip every one of these. Because there's nothing here. On this graph, there is nothing straight up and down, so I can't include that in my domain. So rather than saying it's from negative infinity to infinity and subtracting out a bunch of points, we're just going to say where this graph does not exist. So we're going to say this graph doesn't exist whenever x equals. So x cannot equal, and I'm going to list all the places that there's a vertical asymptote. Now, in order to do that, we need to know the distance between our vertical asymptotes. And that's exactly pi units. So since the distance is pi units, we're going to say it's k times pi. But that is not correct yet. That is not 100% correct. Because k can be any integer. So if I plug a 0 in for k, 0 times pi is 0. Do I have a vertical asymptote at 0? No, I don't. If I plug a 1 in here, I have 1 times pi, so that's pi. Do I have a vertical asymptote at pi? No. So the first two I picked were right here and here. However, if I just shift this over a little bit, then they match up with the ones that actually exist. All right, so we're going to take that k times pi and just shift it. We're going to shift it however many units I need to. And to get from here to here, I'm just going to subtract pi over 2. So it is k times pi minus pi over 2, just to kind of shift it. Give that little kick over. What's the range? What's the range? Jack, do you know the range?
Would it be negative infinity to positive?
Yeah, absolutely it would be. It's the lowest point I can get to, which is negative infinity, to the highest point I get to. Unlike cosecant and secant, there's no gap in between. So I can hold my finger all the way up and all the way down. All right, fundamental cycle. I've said this before. I'm not overly concerned about you knowing that term, but it's negative pi over 2 to pi over 2. It is just the one we most likely will graph, is your fundamental cycle. It is, so let's say we take the quiz tomorrow, and I say graph tangent, just our basic tangent function, all right, tangent of x. All you'd have to do is draw this vertical asymptote, put a point here, go up. Put a point here, go down, and you have it 100% correct. I don't care about these 2 points. I don't care about you marking this. So tomorrow or Monday, if I ask you to graph tangent of x, all I'm expecting you to do is put a vertical asymptote here, a vertical asymptote here, up, and you're moving on to the next graph. Okay? That's all you need to do for tangent. All right, let's go ahead and get into cotangent. Cotangent's got to be similar because they're reciprocals. We're going to run through the values of cotangent of x. Well, cotangent of 0. I got to first find my tangent of 0. My tangent at 0 is 0. So if my tangent is 0, what is going to be my cotangent? Charlie. I'm looking for cotangent of 0. My tangent is 0. What's my cotangent value then? Close? Undefined. Undefined. We need to know that. So if tangent is 0, cotangent is undefined. So cotangent is undefined there. And it's undefined here. It is going to be 0 at pi over 2. And then at pi over 4, my tangent's 1, so my cotangent must also be 1. And the same thing's true for 3 pi over 4. All right, so once again, I'm going to put a vertical asymptote where it doesn't exist, so that's at 0. And pi, I'll put a point, yeah.
Why wouldn't it be -1 at 3 pi over 4?
It should be. It should absolutely be -1. Awesome catch. We're going to put a point right in here. We got our pi over 2, our 3 pi over 2. Let's go ahead and mark those. And at pi over... Oh, that should be pi over 4. Sorry. At pi over 4, we're going to be at 1. At 3 pi over 4, we're going to be at -1. And so our cotangent graph, although looking a lot like our tangent graph, is going in a different direction and has different boundaries. So I find that the hardest thing that students have is keeping straight which one's cotangent and which one's tangent. All right, so tomorrow or Monday, if you take a quiz on this, make sure you know the difference between tangent and cotangent. Tangent is always going up. Oop. Tangent is always going up. Cotangent is always going down. Tangent goes to the origin. Cotangent goes to the pi over 2. Okay? You got to keep those two straight. All right, once again, the distance between our vertical asymptotes is pi, and that's also my range. So my range is, or not my range, my period is pi again. My domain, once again, I'm just going to list the places where it doesn't exist, because it technically goes from -infinity to infinity, but misses a whole bunch of points. My domain cannot be, the distance between my vertical asymptotes is pi, so it's going to be k times pi. And either we have to add something to it, subtract something to it, or leave it alone. And how we figure that out is we just check it. If I plug a 0 in for k, that means I have a vertical asymptote at 0. Got one of those. If I plug a 1 in for k, I should have one at pi. I got one of those. If I put a 2 in, it should have one at 2 pi. I could definitely draw one at 2 pi. It is the proper spacing. We just leave it as x cannot be k times pi. Range, once again, is -infinity to infinity. Fundamental cycle, this one's a little different because it's 0 to pi. Important stuff because those are two brand new graphs. Cosecant, secant, I guess they're new, but you already knew sine and cosine, so it shouldn't have been that big of a. These are brand new, have to be memorized, because you don't want to sit there on a quiz and be timed and trying to figure out all the points that you have to plot. It's much easier to be the person that goes, oh, cotangent, vertical, vertical, dot, doon, doon, and they're on the next problem while you're trying to fill out a table of values. All right, so know these. Know these. Don't be lazy. Yes, Marley.
Can you just explain the fundamental cycle again?
Fundamental cycle is basically what is that thing that most people graph first. So,
Oh, I get that.
so if I ask you to graph it, you could technically pick one of the cycles way out here. But you probably wouldn't do that. You're probably just going to graph this one. It is our fundamental. It's the one everyone accepts as being the main one, and everything else is a repeat of that one. Yeah. Good question, though. Thank you for asking. All right. Transformations. Like I said, forget everything we know about sine and cosine. Yes, things are still true. Things affect our period the same way. Things affect left or right. But how we graph these are going to actually change. First of all, big change. Cotangent, tangent, period will be pi over b. The past few weeks we just used 2 pi over b, but that only works with sine, cosine, secant, and cosecant. When I'm asking for the period, it has to be pi divided by b. I'll say it again, it has to be pi divided by b. If this circling is enough for you to know it's important, fine. Otherwise, highlight it, point to it, it's important, it's a big change. The second thing is, when we graph these, how we're going to graph them is, don't get too mad about those. They'll make sense. Those will make sense in a second. We just want to put one vertical asymptote, a second vertical asymptote, and just draw our tangent or cotangent in between those things. So our primary goal when we graph these is to graph 2 vertical asymptotes. All right? Which means most of the time we're not going to worry about the period. We're not going to worry about shifts. We're just going to use these 2 equations to come up where my left bound and my right bound is. And once we get into it, it'll make more sense. All right, here's the cool thing about what's going to happen. Ooh, I have this wrong compared to you guys. You guys should have 2 tangent 2 times x plus pi over 2 plus 1. Correct? That's what yours says? Okay, cool. Amplitude. We aren't going to worry about amplitude with tangent. Hold that statement for a second. We will not worry about this unless it's negative. If it's negative, it has to flip. Otherwise, we aren't going to let amplitude affect our graph. It does a little bit, but not enough, and I don't want to plot those points. All right, I want to make this nice and easy on you guys. I want to do the most important stuff. So amplitude, we're not going to worry about amplitude with tangent or cotangent unless it's negative. You might want to write a note to yourself regarding that. So amplitude, only if it's negative do we care about it. So I'm not going to worry about that guy. I am going to say this is important. We're going to go up 1. So our 2 checks. Is this negative? No. I'm going to jump straight to does it go up or down? If, because in the homework it'll ask for your period. Remember your period is pi over b, so this period would be pi over 2. But we're not going to concern ourselves too much with the period. I'm going to write it down just because I believe the homework asks for it. So our period for this one is going to be pi over 2 instead of the 2 pi over 2. But we're not going to plot any of that on there. I'm not going to do pi over 2. I'm not going to do any of that. What we're going to do instead, we're going to jump straight to circling this guy. And we're going to set up 2 equations, and I'll talk about where these 2 equations came from. We're going to set up one that goes 2 times x plus pi over 2 equals negative pi over 2. And the other one's going to be 2 times x plus pi over 2 equals pi over 2. Right now, even if you're semi-inquisitive, you'd be like, what does any of that mean? Where did any of that come from? Well, just remember that the period is embedded here, and so is our shift. This is going to be shift left pi over 2. Both those things are embedded in this equation. What we're trying to do is, notice on the fundamental cycle, we have a vertical asymptote at negative pi over 2, and we have one at pi over 2. I want to see how this equation affects this bound. So will it move it left, right, and what value is it going to be? And I want to know what effect it has on this bound. All right, so those two equations are just asking how far and where does this one move. And the other equation asks how far does this one move. All right, so we're going to go through it and we'll see what it means at the end. So if you're still a little confused, we're just going to go through it and hopefully that clears everything up. I don't want to waste any of your time. 225. Okay. So we're just going to solve for x. All right, simple algebra. We're going to solve for x. So this is going to be 2x plus pi equals negative pi over 2. I'm going to kind of go through this quickly. If you get stuck, just do the math at home. We just don't have a ton of time. I'm going to subtract pi from both sides. Right? Subtract pi from both sides. That will give me 2x equals negative pi over 2. I'm going to change this to minus 2 pi over 2, just so I have a common denominator. Then we'll have 2x equals negative 3 pi over 2. Divide both sides by 2 and you're going to get x equals negative 3 pi over 4. If you miss some steps up there, just try it on your own. Make sure you can do that. All right, we're going to do the same thing for the other side. All right, we're going to distribute the 2, so we have 2x plus pi equals pi over 2. Then we have 2x equals pi over 2 minus 2 pi over 2, which would give me 2x equals negative pi over 2, which is going to be x equals negative pi over 4. If you're doing this and you catch a mistake, just let me know. Sometimes when I power through this stuff, I make little mistakes. We're almost done with our graph. All right, we're not going to do some crazy marking here. We're just going to say to ourselves, well, negative 3 pi over 4. I got negative pi over 4, so we're just going to make a mark, and that's going to be our negative 3 pi over 4. And then we'll just make another mark, kind of just approximate it, and that'll be negative pi over 4. And we're going to put our vertical asymptotes at those 2 points. Then we're going to take a big old point and put it smack dab in the middle. Now we just got to remember the shape of the tangent function. All right, the shape of a tangent function, I'll go back to it, is it starts low and gets high. So all I'm expecting you to do with this shift, graph this, go like this, go like this, and I should have marked this as 1, maybe 2, negative 1. Nope, we're done. We are done. We're only concerned about that 1 point with tangent. Like I said on the test or the quiz either tomorrow or Monday, when I ask for just the tangent graph, you're just going to go boom, boom, 1 point, and you're done, and you're moving to the next one. Okay? It should be that fast. Because we won't have any vertical shifts or anything, or any movement. All right. And the last thing I need to do is up 1. So we're going to go up 1. Ooh, I shouldn't have picked red. Oh, well. Let's just change the color to purple. So we need to just go up 1. And just go like that. And we're done. All right, any questions on that? Yes, Liam?
Where did those two, how did you get those two equations?
I got them from, I mean, there's a big story behind where they came from, but in just context of a quick answer, our period and our shift is embedded in this section here.
Yeah.
All right? So setting it equal to where our vertical asymptote normally is, we'll actually shift it to where it needs to go. All right, so this equation is set up to actually move. So it moves, let's go back to, it moves this vertical asymptote to where it needs to be. All right, and then the other equation moves this one where it needs to be.
Oh, okay. So it's basically psi times two asymptotes.
Yep, it's exactly what it is. You said exactly what it is. It's just to find our two asymptotes. All right, and we're going to do one more. This time we're going to do it with cotangent. Look at your cotangent graph real quick. Flip it over and look at your cotangent graph. Note that that has different beginning asymptotes. It has one at 0, and it has one at pi. That's why we set our equations equal to 0 and pi in this one. For tangent, it's negative pi over 2 and pi over 2. For cotangent, I'm starting at 0 and pi and then shifting it. All right, I'm going to look at my amplitude. My amplitude's not negative, so I don't care about it. All right, I kind of care, but I don't care. It's not going to affect my graph. All right, it's not going up or down. I could, if I wanted to, list the period, but it's not that important unless I specifically ask for it, so let's just put the period. It is not 2 pi over b, it is pi over b, which is pi over 3. But the most important thing is taking this entire thing and setting up our two equations. I'm going to distribute right away, so I'm going to have 3x minus 3 pi equals 0. And I need to shift that other vertical asymptote, so that would be 3x minus 3 pi equals pi. So these are my original vertical asymptotes. That's where those come from. So if you know those, you know this equation. All right, then we just go ahead and solve. So I have 3x equals 3 pi, x equals pi. One of my vertical asymptotes is at pi. I don't want to graph it until I know the other value, because there are times where these kind of switch sides. All right, so let's go ahead and solve the other one. That's going to be 3x equals 4 pi, which will be x equals 4 pi over 3. Well, pi is smaller than 4 pi over 3, so I'm just going to mark a pi here and mark one that says 4 pi over 3. I'm not looking for it perfect that you have it out here super tiny. I want it nice sized in the positive, something that looks like that. We just got to throw two vertical asymptotes through there. All right, I'm just going to, just for the sake of it, 1, 2, -1, -2. And now all I have to do is know the basic shape of my cotangent graph. So tangent goes up, cotangent goes down. So we just put a point in the middle, kind of go like that, and that is our cotangent graph, and we are done, because there's no vertical shifts up or down. All right, the only thing we didn't cover is if this was negative out here, it would just flip it all. All right, that's the only thing we didn't cover today, is if it was negative, we'd flip it. Liam.
So if it was negative, this starts high and gets low, and then if it was negative, it would start low and get high.
Yep.
Okay.
All right, any questions? I know it almost doesn't feel as satisfying, because we used to be able to go left and do our whole pi. Now we have like these two equations that help us shift. But trust me, it's way easier than trying to copy down your period, and then trying to shift stuff, because your period's got to like keep changing with it. This is just the easiest way to do it. All right, questions, comments?